Welcome to the 4D PNR layout tour of the month for March 2023. Today's layout tour is a panel discussion. We're trying something different that I don't think we've done yet on the 4D PNR layout tours, and that's have a whole group of speakers talk about one topic. And today, the topic is an interesting one. It's aluminum benchwork for model railroads. A number of people have been using this material. A bunch of us have been aware of it, but have not used it. So we're on the cutting edge, so to speak, today. And I want to thank Magnus Christerson for bringing this to the table and organizing a group of speakers participating today. So as you can see on the screen, I'm the moderator, Lee Marsh. And then today we've got panelists who are all involved in using aluminum benchwork in some form. We've got Magnus Christerson, Dave Kreitler of North Bend, Morton Grosser of the Bay Area, Burr Stewart here in Seattle, and Jim Betz from Burlington, Washington. And so we're going to go through a format that is about 5 to 10 minutes for each of these people to speak and give you an idea of what they're doing. Magnus Christerson is our first speaker. Magnus is a semi-retired software engineer and new technology startup executive here in Seattle. He returned to the hobby after many years thanks to the pandemic, didn't we all? And to assess his interest level, he built a small traditional layout using lumber in an open grid with XPS foam on top. He's now working on a much larger sectional layout along the walls with some peninsulas, and he would like sections that can be moved or replaced easily. And so he has chosen aluminum benchwork. Magnus models the current area of BNSF in the Seattle subdivision from King Street Station to Tukwila, and he also plans to include a small European section on his layout.
Okay, great. Yes, Lee mentioned I'm planning my second layout here in Seattle, and I've been thinking about how to build it and what I want from it. And one of the things that stood out was the ability to change and move the sections and replace sections, both height as well as where they are placed in the layout. Also be able to work on electrical stuff underneath. I like just to lift them up and work on it. So this is typically not accomplished with traditional lumber type layout, which I have currently. So I've been looking at aluminum after I met Mort Grosser. He showed me his layout, which he will present later on. And I think, wow, that's an interesting topic. And I found a few people locally here that's also on the panel today. So why am I interested in aluminum for benchwork? As I mentioned, the ability to change is a big one. And maybe the ability to move sections, both replace them as well as move them to my workbench. I also find that the precision of model railroad is very important, and having precise control of exactly where the benchwork sits will be valuable. There's also lightweight, as I plan to move it around and maybe even move houses in the future, as well as modular, so I can replace sections. I'm also tired of all the dust that comes from wood, so if I can minimize the dust, that would be value. I've also been thinking a lot about how to get younger people involved, and I think aluminum is a better material for young people as they are used to it from like robotics classes in high school, and most young people don't have access to a good wood shop. So maybe aluminum could be a way to help young people get started in the hobby. Let's see. So what is aluminum? Aluminum comes in multiple forms. Extruded aluminum is what I'm looking at, and that is aluminum that pressed through a form or a die. It looks kind of like this small channel that are very lightweight and very strong. And these aluminum profiles, they come in a lot of different shapes, like you see here. And essentially you build modular sections and put together these profiles through different types of fasteners. And the fasteners come in all types of shapes. There's a number of them that are examples. And then you bolt it all together through different types of T-nuts and bolts. And here's a few of them that you insert in the channels in these profiles. And then you have an Allen wrench, and essentially that's the only tool you need to put together pretty sophisticated systems. So my layout, I'm thinking of around the room shelf layout. I want to minimize anything that touches the floor. So the shelf layout is what I envision. And I envision having these profiles bolted onto the walls and then hang cantilever out extrusions that hold up separate sheets like this. So I started doing some experiments and see how well will this actually work. So in my garage, I put up a few extrusions like this for experiments. So here to the left, you see a double profile. You can see that I have two slots in there that I can bolt on cantilever parts to. Then I would put frames like this on top and bolt them on. And these frames would then essentially carry the sheets that we would build a layout on top of. And then since I'm bolting it, I can move it up and down. I can take it off and move the whole section, is what I'm thinking. And then on top of these frames, I would bolt on a very lightweight surface, like, for example, in this experiment here. So then I'm thinking, okay, how strong will this layout be? So I did a few experiments. So on the design to the left there, by having this extrusion be about 18 inches, I put some weight on them. And of course, they're not very strong on themselves, but by enforcing them with steel brackets, with using a gasset steel bracket, I easily could load it with 30 pounds at the edge there, as you see in the picture. There's a smaller L bracket you see in the second circle there, that's tiny, and that could hold 20 pounds. So this will be plenty strong for what I'm thinking of. Also, I'm interested in the deflection. We know that wood deflects quite a bit, so you need to hold it up in several places. Aluminum are much more strong and in terms of things like tensions and so on. So the deflection, the theoretical deflection, you can calculate with the formula here. And a 24-inch extrusion with a 25 pounds load theoretically would deflect only a 1/4 inch, which is about what I observed in my experiments here. There are several suppliers of these aluminum extrusions. The biggest one in the US is 8020. I bought a number of pieces from them. They are the largest US-based supplier. The catalog is over 1,000 pages, so they have all types of aluminum material. They also provide custom machining services if you want to have something special built. And they also now sell on Amazon. And speaking of Amazon, there's a lot of vendors on Amazon selling these extrusions. A lot of them are China-based. And there are also many smaller US suppliers, including a company called tnuts.com, which sells brackets and fasteners for the 8020 system. Now, if you mix and match, you should be aware that there's no standards in this space. So if you buy an extrusion from one vendor, that might or might not be compatible with an extrusion from a different supplier. Same thing with fasteners, they might or might not work together. So if you plan to mix, which I'm thinking of, you have to try it first and essentially build out your own standards here. The costs here, I bought a few different pieces here, and here's an example. You can compare the 8020 prices. So I bought, if you buy 10 of the, like a 40-inch, was called 2020, which means 20 millimeters times 20 millimeter size. You pay about $125 from that, and 8020 will ship that to you like within a week. The same type of extrusions, like 10 of the 40 inches on Amazon from a Chinese supply would be $80. That was cheaper too. And that's about 64% difference. Now, this is not a big difference. So I'm thinking I would primarily go with 8020 here, since there's a good quality and you know what you get. However, the fasteners and the brackets, that's where they get you in terms of cost here. So there are just a few examples of things you might need. And you can see that the price difference is quite significant, especially for the smaller pieces. Then finally, on what surface would you put on? I investigated 3 different ones. Gatorboard, which is a very stiff, much stiffer than like a pink foam, and it has a veneer of wood fiber. This is fairly common also in the model railroad community. Gatorboard is very popular. There's alternative to Gatorboard, since it's paper or wood on the veneer. Ultraboard is an alternative, which is exactly like Gatorboard, except it has styrene as a veneer. And then there's precision board, which is a different material. It's high density urethane, and it's very, very, very strong. And it can be carved in machine, and you don't have any veneer on that. And Mort will talk more about precision board later in his presentation. Okay, I think that summarizes my section here. Thank you.
So I'll introduce Dave Kreitler, who's up now and will be our next speaker. Dave's still working full time, but getting into the hobby after over the last 5 years. And he's got a layout in a room 13 by 17 feet, double deck in scale project, representing a fictional GN branch in the Pacific Northwest. And time frame is 1968, 1970. Benchwork goes around the walls is hollow core door sections on shelf brackets, but there's an 11-foot double deck peninsula down the center of the room that's composed of more door sections, and they are supported on aluminum framework. The around the wall portion features a 7-foot removable section for access to a large window, and they will show us this. And the section supported on an aluminum frame with wheels, so both decks can easily be moved aside when needed. So simple aluminum frames are also used to support a canyon section and a 36-inch diameter helix for traveling between decks.
My introduction to aluminum was a number of years ago. I encountered a group of Australian narrow gauge modelers that were experimenting with aluminum frames for modular display layouts. At the time, I was involved with the 4th Division N-scale modular group also, so I had a lot of interest in the problems with doing modular railroading. And so the aluminum idea was very appealing to me. From my perspective, the advantages of using aluminum are the stability of the material and the uniformity. You know, wood is very easy to work with, but weather impacts it and age impacts it. The thing about aluminum is it's straight, it stays straight, doesn't matter if it's hot or cold, it stays uniform and straight and strong. And that strength to weight ratio also was appealing, especially because, like I said, my initial interest was from a modular perspective where you've got to be loading modules and moving them a lot. So that's where aluminum caught my interest. So Magnus did a great introduction into the components. I found that 80/20 is my preferred manufacturer due to their quality level. And they have one other profile that he didn't mention, and that's one they call quick frame, which in this picture, it's this plain square tube at the top, in the top row there. And quick frame has its own set of connectors that are made out of a nylon that make it easy and fast to assemble pieces. I'll have some better examples of that in a later slide, but I wanted to show the quick frame because it's just square tube, fast and easy to use. A lot of the other uses are for the T-slot profiles. I want to reinforce his point also about fasteners. There's an astonishing array of fasteners that allow you to build this stuff. 80/20 is a tagline. They call themselves the industrial erector set. And that's because you can just do so much with everything. But the fasteners is where they make their money. A slightly different perspective, just looking at individual fasteners at 80/20, you can pay cents up to tens of dollars for a single fastener. So you want to be really aware if you start looking at what you're doing and you're interested in the specific fasteners, pay attention to the cost. I found that for the work that I do, the only fastener I decided to actually purchase from them for the T-slots were the T-nuts. They take a standard 1/4x20 bolt, and that ended up being all I needed for everything that I put together. For the quick frame, I do use the nylon joiners, but they're much more affordable than the metal fasteners for the T-slot material. All of these things, though, they're available in both metric and standard sizes, depending on how you want to go about building your project. The one thing I also want to touch on was tools. As far as what special tools are needed, well, really not a lot of really highly specialized things. The one thing you'll want is, I really recommend a chop saw with a carbide blade in it. The example I have here, I actually bought the essential equivalent of this blade like 20 plus years ago. I'm still using it. I've never had to sharpen it. It cuts the aluminum just fine, and I still use it for all my wood projects as well. And it cuts like butter, and it has never showed any sign of dulling over that span of time. A good carbide blade. And then the other thing is our drill bits. Make sure that your drill bits are specified for metal work. I mean, I have some nice brad point drill bits specifically for wood, and that's the one thing, you don't want to use those on aluminum, but any just standard metal bits will work just fine. One of the other talking points they had was, is aluminum an alternative for wood? For me, I find that for supporting the railroad, definitely aluminum is a great alternative. And it comes back to that strength to weight ratio and the stability and the fact that it doesn't change with the climate. So here, just do a quick review of some of the project work that I'm doing. I've had an interest in modular railroads for quite a while, and this latest go around started in a friend's garage about 4 years ago. He wanted to build down one wall of his garage, but then have a temporary section that could be set up in the center of his garage. And on the left, what you see is the idea that we came up with for supporting the temporary portion. And this uses the T-slot components for the verticals and the quick frame tube components for the horizontals. And you'll see that this served as the inspiration for the peninsula in my current railroad project that I'm working on now. On the right-hand side, this is just a kind of a top view of what my current train room looks like. And I want to talk about the different sections. I'll start with A. This is the peninsula. This is where the aluminum is really shining. What I have is an 11-foot peninsula that extends out into the room. In the left-hand picture, off in the distance there, you can see two verticals. Those are two 1-inch by 2-inch T-slot components. They're actually bolted to the wall, and that provides just the stability for the whole peninsula. And then what I did is I used the T-slot verticals and built 3 posts to run the length of the peninsula. And in the lower right-hand picture, you can see there's stringers that run from post to post to manage the spacing there, with cross arms that actually end up supporting the door slabs, which are the actual benchwork for the railroad. Another sort of feature you can see in the lower right-hand picture, you'll notice in the distance, the arms cantilever out, and that's supporting the far end where the peninsula, the track, does the return loop back down the other side. And this is one of those examples where it's really simple because of the strength of the aluminum, just a couple of arms and you're ready to go. It doesn't require a lot of other engineering to worry about a whole bunch of flex. And so here in the upper left, you can see the door slabs in place on the cross arms. The verticals extend up. At the top, I'll be able to support my lighting and fascia. And vertically, on the vertical surfaces, I'll be able to support the skyboards. The next picture over, you see a close-up of the feet. By putting T-nuts in, it allowed me to put in height adjustable feet, so I could do fine tuning of the adjustments to make sure that I was plumb and square. The other thing to note here is sort of like what Magnus did on his walls. I used steel shelf brackets to provide just some great rigidity to support the vertical posts and make sure that they stayed square. Using steel shelf brackets is fast and easy and strong, but whenever you buy shelf brackets, you want to make sure they're truly 90 degrees. Some of them are not quite 90 degrees, and so you want to check that when you're purchasing them. And the other thing is using T-slot aluminum, the slot is centered, and not every shelf bracket comes with the holes centered. So it's just another thing to be aware of. But if you find them, they're fast, easy, and incredibly strong. So then moving to the top photo on the right-hand side, here you can see I added crossbars to the top of the verticals, and these were for supporting the framework that ultimately will support the lights and the upper fascia around the top of the layout. The bottom right-hand corner is essentially the same photo as the top right photo, except the camera has been moved a foot lower and a foot to the left. And you see the lights are in place, the skyboard's in place, the upper fascia's in place. That's kind of just how it all comes together. Some of the other projects that I have, unfortunately, the largest window in my house is in my train room. And I need to have access to the window. And so using my modular experience, what I came up with is the 2 deck pieces that cross the window, I'm building them as modules. And this cart that you see in the first photo, this supports the lower deck and the upper deck modules. And it's on industrial casters. So I essentially can remove some bridge tracks at each end of those modules, 2 C-clamps at one end, and this whole section of railroad just pulls away and rolls down the side aisle to be out of the way for access to the window. This cart is all made out of 1-inch T-slot aluminum, with the exception of the actual horizontal arms at the top to support the actual railroad sections, and those are just 1-inch tube quick frame. I found a couple of steel gusset plates to use to reinforce the actual corner joints to reduce any kind of flex that's in there. And once in place, because this is firmly fastened at each end, this is plenty strong, and there's no problem with deflection, even if you lean an elbow on it while you're sitting there working or looking at the railroad. The picture on the right-hand side, top row, that's the modules pulled out and rolled down the side aisle out of the way, kind of what it looks like. Another thing that I used the aluminum for was I had to span that window, which ends up being about a 7-foot span in order for the lights in the upper fascia. And so I wanted something, once again, strong but light, because I had to be able to remove it if I had to get at the window to do work on the window. And so I used the 1-inch aluminum tube. The one thing that's a little bit different here is, if you look at the lower right picture, you'll notice that the tube there has 2 flanges on top of it. Well, the quick frame aluminum, you can get in plain square tube or with single flanges in order to like bolt panels to it, or the double flange that you're seeing here. This is made so that you can take either like a 3/8 inch piece of acrylic or a 3/8 inch piece of plywood and press fit it down into that flange in order to, like, if you were framing up a box and you needed to solid walls or that kind of thing. But what was good for my application here is I needed to span 7 feet, and that extra 2 flanges make the tube even more rigid. So it just provided a little bit more support for my lights that go across this section of the layout. And then lastly, doing just frames, this is where the square quick frame with the nylon connection and corner pieces really shines, because you cut your tube to length and then you just pound the nylon fittings into the ends, and it goes together in minutes. On the left-hand side, I have a square frame with adjustable feet that is used. That's how I support my helix. Just the other items there is the short piece of horizontal tubing you see on the top left. That supports the upper deck module when it connects, and the lower horizontal piece that you see, that supports the lower deck when the modules are in place. Another example on the right-hand side, I have one place where I'm building a slight canyon below grade scene. I call it the canyon module, and it's just a simple plywood framed up box. But once again, I used the 1-inch aluminum quick frame to provide the supporting framework underneath with adjustable feet. And that whole assembly, once again, it went together in just a few minutes because the 1-inch square is so easy to use. So what are my lessons learned after using aluminum? One of the things I like about it is the adjustability. Because I use T-slot for the vertical supports in my peninsula, if I decided I wanted to change the height of my decks, it would be pretty straightforward to do, because I only need to loosen some bolts and I can adjust the level of each deck because it'll just slide up and down in the slots. Another lesson though, because I like using the quick frame, which is the square tubes, you really want to plan ahead. Nut bolts placements, you really want to be aware of where your nuts and bolts are going to end up being, so you have tool accessibility once components start getting assembled. Another one is precision. There's one of these things, I know we're all model railroaders, we've all built a lot of wood bench work. We all have dreams of being cabinet grade carpenters, but we all aren't necessarily. And the thing about wood is you have a little bit of a fudge factor, you know, especially like if over time you have a piece that's a little bit out of true, you can usually screw it together, and as you tighten down the screws, things will kind of pull together and everything's fine. The one thing about metal is your holes have to align perfectly. If they don't, there's no fudge factor. So it does take a bit more precision here if you're working with the aluminum. And that's where it comes around to the right tools make this pretty easy. Once again, I'll say carbide blade for your chop saw. One thing here is a drill press. A drill press is nice if you have one. It's not absolutely necessary, but it is handy if you have one because of the precision. And then the other thing I would just want to touch on is I call it one wrench to rule them all. I found that I could use standard 1/4x20 bolts to do all of my assembly. Yes, they're in different lengths, but they're all just one standard bolt. And so I can literally take one wrench into my train room and adjust all of my aluminum everywhere with just that one wrench, because I picked one size, it worked with my connectors, and away it went. Thank you. That's pretty much it for how I've used aluminum.
Thank you, Dave. That was really interesting. Our next speaker, who is Mort Grosser, he's an engineer and neuroscientist, works in venture capital, and he lectures at Stanford and Emory universities. Mort's dad built a Line L layout many years ago, got him interested in trains, and since he's built 5 layouts, all with wood substructure. But the layouts have included various US and European prototypes, but he's got a new layout in progress with no wood in it, and he's using CAD-designed Aluset aluminum space frame and PBLT proofboard surfaces. It's a European layout, and the track work is in place, but still as yet unlandscaped. The layout's also going to have a hot catenary when he's all done here. So, Mort?
Thank you, Lee. I'm the only European modeler on this panel, and if you look at this case, it represents a small portion of my collection, but the trains in the case run from Epoch 1 on the bottom track to Epoch 6 on the top, and they're from 4 different European countries. Here's freight and arranging the same thing. I wanted to build a layout for my limited space in this particular application. The space I have is about 3.75 meters by 2.54 meters, and I wanted it to represent something reasonable. So I settled on the idea that the entire layout would represent a European railway museum. It's called GRM, the Grosser Railway Museum. It's basically flat, but it will have a helix and a subterranean Schattenbahnhof, a storage yard, and it will also have a semi-canyon underlaid with bridges over it. But the basic layout is flat. I decided years ago, when I was building timber layouts, that it was ridiculous to be building a 50-kilogram structure to support locomotives that weigh 250 grams and cars that weigh 50 grams apiece. From an engineering standpoint, I was first interested in aluminum because of going to so many tech conferences where the exhibition booths were assembled overnight by unskilled labor, basically, and went together and stayed rigid up to the size where they had real doors that you could walk through, chairs that you could sit on, and in some cases, stairs to a second level. And I found that those were made, many of them were made by a company called Aluset, which is a German company with an American headquarters in Wisconsin. So I contacted Aluset. Like all of us, I have certain aspects of the hobby that I like better than others. And in my case, it's super detailing and scratch building many of the pieces of rolling stock. So I have details in all of my layouts that in the past were at normal layout height. This time I decided to make an adult layout where these details could be appreciated. And this is a sample. Here's a Swiss rail car on one of our European train enthusiast modules. This is a famous train in Switzerland. It's a rail car, and it pulls a detailed car that's called La Bucanada. It's a tourist diner. And yes, there is food on the table, ware in the hands of the guests, beer in the glasses, and goulash in the pots. So I decided to make this layout much higher than I'd ever built before, and I contacted Aluset to help me out. This is a temporary layout on the floor. It includes a possibility of running 5 trains, 2 in HOM, and they're surrounding a museum building, a main museum building. There are 6 museum buildings. and a main line, much of which will be undercover, very similar to French layouts where you see only partial. That will be mainline traffic going around. But all of these things will allow me to run clean, shiny trains with no graffiti and buildings that are kept in good condition. This is the frame that I designed for the layout. My son put this into CAD. We worked on it together. And this is the original CAD drawing, except that the ones that we sent away to IUCET were completely dimensioned and it's all metric. I apologize to all the true inch guys watching. We're a metric household. and so everything is in millimeters. This is the frame that measures the same dimensions that I just gave you, 3.75 by 2.54 meters. We sent it to them on August 17th, and 9 days later, a pallet arrived at our workshop with these parts on it. This is a completely modular system. It uses only one form of connector for 90% of the connections. And that connector is so rigid that there is literally no deflection on the extensions of these if they are cantilevered. There are no cantilevers in my particular layout, but I did test for it. These pieces arrived in 9 days. We decided to check a few of them. They're labeled for length, as you can see here. And every one of them was plus or minus 1 millimeter, plus or minus. So we put together a test section. This is the first thing that I assembled to see what it was like. It was assembled with a single 4 millimeter Allen wrench. These connectors, you can see this little circular dot there. That drives a worm drive. It's connected to the T-slot so that when you tighten this up, the connection cannot be moved. If you were to try to bend something like this, it would probably break off before the connector would let go. It's absolutely square, plumb, and level. It took 10 minutes to put this together. And I thought, aha, this is the kind of thing that I envisioned, because I would like to have this layout assembled without all the hassle of all the timber and all the sawdust and all the crawling underneath that I used to do. So my son and I put the whole layout together in our workshop. This took 2 hours for 2 people to erect and came out perfectly. We didn't have to adjust a single thing. The double frame section in the foreground is going to be a lower level. This will be cut away. It's spanned by 3 bridges. It was fashioned to model the entrance to the Köln Hauptbahnhof in Germany with the 3 magnificent bridges across the lake there. And this will be sort of like that here. You can stand in the middle of that hole, and that's the operator section, and one person can lift this layout and move it around easily. It's plumb level, and every vertical leg has a leveling foot on it and a pivot to adjust the floor inaccuracies. There's another view of it, just to give you an idea. All of these radii were specified by us. They came back exactly as specified in 9 days. We did this on our laser. We have a laser router in our wood shop. This is PBLT precision board. This is 30-pound board. It can be machined. You can tap into it. It will hold screws as well as plywood, better than plywood. It has no grain. It doesn't warp, swell, rot, or change with time. It's fireproof. And I decided I will never go back to it again after using it. It's just a pleasure to work with. It's fastened to the layout with stainless steel screws that you'll see later all around the circumference and everywhere where there's a T-slot. It uses one 4 millimeter Allen wrench to assemble the whole thing. Here it is assembled in the room where it's going to live. I wanted to emphasize another thing about access. After crawling around in the dark, this layout will have light strip LED work light under it. But if you look at the spaces between the uprights, it is so easy to sit on this stool. What this is a pedicure stool. It's exactly the same qualities that you would get in a medical setting, except it costs about 1/3 of what it would cost otherwise. And it has a hydraulic lift in the center of it, so you can sit under your layout and wire and solder in complete comfort, and it rolls around. It can easily be lifted over the other things. I have found this to be a great help to me. This is a close-up of that connector, and these little nylon slides are one of hundreds and hundreds of accessories. IUCET makes the tape that matches these perfectly for the curtains that will slide around, and it has close to 1,000 options of things to hang attach or do this. The finish on this, you can see the satin aluminum finish, is a pleasure tactically to work with. And it saws beautifully. And the connector is super, super tight. I can't emphasize enough how strong and light it feels. You can see the PVLT board and a little bit of a road bed above it on the standard gauge track. Here's the track layout dummied up on the top of the layout. The buildings are mostly built already. My late wife was an expert constructor and part of my layout, and now I should mention I'm engaged, and my new partner is an equal partner again in building this layout, a remarkable thing. So there are 6 pre-built, pre-lighted, pre-animated buildings that are part of the museum layout, and the main building of the layout will go on that lucite baseboard that you can see in the middle of the HOM. I'm also putting in a Magna Rail section for those tiny working bicycles. It's a Dutch company and a French subsidiary that makes HO scale bicycles and little carriages that move around very realistically. That's another view of the layout. That's my son. It's a shout out to him because he's been part and parcel of this process from day one. And we've had a great time doing it. It's fulfilled our expectations in every way. I will go back to cost because this is orders of magnitude different than if you were to buy extrusions from 80/20. The bid that Aluset gave us originally was $1,980. And when the pallet arrived with shipping, insurance and everything, it was $2,300 to build a layout. I never did do an economic analysis of the wood or the plywood or any of that stuff that went into my timber layouts, but I can say that this was worth every penny to me at this stage of my life. So thanks a lot.
Well, thank you, Mort. That was really interesting. And I really like put the CAD drawing together and send it off, and then it shows up on a pallet later. Of course, that's part of the $2,300, but hey, that's just in the realm of a brass locomotive these days. And you got a whole layout.
Right.
So thank you. So our next panelist is Burr Stewart. He's a semi-retired Port of Seattle planner, has been building an HO model railroad of the BN Seattle region in 1973 for the past 35 years in an 800 square foot basement. Most of his bench work is traditional L girder out of wood, but he's experimented with a variety of approaches and recently built a turnaround loop for his narrow gauge branch out of gator board resting on aluminum C-channel near eye level to keep everything light and removable for access. Now he's planning a lower deck extension to model the West Seattle steel mill and is working with Magnus Christerson to design it as a series of lightweight modules using extruded aluminum and gator board. So he's picking up on this trend. Burr's layout is featured in the January 2008 Rail Model Craftsman, and it's well documented in videos on his YouTube channel, which I love the title, Much Fun with Trains.
My presentation is really going from the sublime to the ridiculous because Mort just showed you a really professional engineering solution. And I'm just showing a shortcut that I came up with one day. I was trying to think of how to make a very, very thin benchwork underneath a high shelf on my narrow gauge extension because I didn't want to block the view of the standard gauge regular part of the layout. And I was thinking I might consider steel. And one of my next door neighbors is a master welder. And I asked her about it. She said, oh, it'll be much too heavy. Just use aluminum. You don't have that much load, which also gets back to something Mort said. Why over-engineer these things? You can see what I did here was to take a piece of C-channel, which you can buy at any home improvement store. I just bolted it onto the center column in my train room. That created the support for a huge shelf, which I'll show you here shortly. This is the 2 aluminum beams that supported a whole new area that I really needed for the narrow gauge because I needed a turnaround loop. So it had to be about 5 feet wide. And of course, you can see there was a lot of fun stuff below it that I didn't want to obscure the view too much. I found I could hang the beams from the ceiling as well as bolt it to the main house beam. I hope that I'm not down in the basement when we have the big earthquake, because I'm sure this will be quite a thing to watch come apart, but never mind. This shows the mock-up that I did early I'm using a 1-inch gator board for the surface, and it has quite a bit of rigidity, so I didn't need more than this for supporting these pieces of gator board. And you can see both from underside and the top down that this really was not creating a problem of obstructing the lower level, and it was giving me a major new addition to the layout. This is another view of the underside. Another advantage of this was I was able to put the wiring inside the C channel. These are connectors that I found out about from Larry Sloan, who was using them. After I took this picture, I just drilled 2 holes in the gator board, took these 2 wires up to the track through the gator board, and I was live with running trains. I got a little carried away once the aluminum was in. I realized that I had been staring at a bunch of very ugly wires for a number of decades and that I needed to clean that up. So I think this might have been Magnus's idea to just put a piece of styrene in front of those wires. And I ended up using aluminum angle to hold the styrene. And of course, this is all removable if I need to get at these wires for some reason. This is a finished shot of how it came out. I'm really pleased with it. I painted the front edge of the gator board the same fascia color that I use on the rest of the layout. And now I have a way of running narrow gauge trains somewhere and turning them around to run back. This is the view from the other side. You can see the turnaround loop. And I'm having a lot of fun figuring out how to connect this section of the layout to the rest of the layout. That's a whole nother subject of how to build bridges across wide open spaces that have no scenery under them. The other thing I wanted to point out with this picture is I finally decided, in order to keep from putting the lower deck under too much shade, I would leave the center of the turnback loop open so the light from the ceiling could come down onto the lower deck. Again, this is a shortcut. Obviously, I could put some tape lights all around underneath this deck if I wanted to, but I mainly just wanted to get trains turned around, and that's what we accomplished here. This is the overall view when you come into the basement, and you can see that this new shelf, while it's perilously close to the air ducts in the ceiling and is so high that Magnus and I are about the only 2 people in the city that can actually enjoy this part of the layout, but it's definitely met the objectives, which was to turn the narrow gauge around without obstructing the view. And if you look in the distance just to the left of that vertical post, you can almost make out the main line all the way across the other side of the room. And that just illustrates that even from the stairs coming down, the profile of this shelf is very, very thin and is perfect for this situation. If I had used wood for this, it would have been too thick and there would have been too much deflection. So I think that's my bottom line. Thanks.
Thank you, Burr. That was a really nice little walk through what you're doing on an existing layout and how you're using aluminum to a great advantage. So next up is Jim Betz, who, like most of us, started his model railroad journey as a kid with a Lionel set up in his home attic in Anacortes, Washington. And like most of us, he stopped playing with trains for a long while he moved to San Francisco, did a degree in math, worked in software at IBM, and in 1985, became re-involved in the hobby with a local club and really was involved in operations at that club. All this without having his own layout. Then in the fall of 2018, he and his wife moved to a house in Burlington, Washington, with space for a layout. It's a large walkout basement for soon-to-be GN local branch. And for this pike, Jim chose to use extruded aluminum because he could and because it made sense to him. So, Jim, take it away.
I want to start out by commenting on the fact that today is the 3-year anniversary of the WHO declaration of COVID as a pandemic. And the reason why I'm mentioning that is because my layout was started construction in the fall of 2019. Then COVID hit and I had to build my layout by myself because I couldn't have people over. Okay, so you want to build a layout and you think you might want to use aluminum. Here's my layout, the early days of the Benchwork. Just left of center, you see a vertical post coming up from a white foot on the carpet, and then a 2-level H that forms a basic structural member. If this was a bridge, we'd be calling it a bent. Then on the right side, you see another one that has a very long reach. That's about 6 feet across there. The lower layer is my staging, and the upper layer is my visible layout. And here's from the other side, looking back at it. I used cardboard that I just cut out into shapes to form what the tabletop would look like when I'm done. Again, you see these H's holding everything up, and there's these feet underneath all of my verticals. This layout sits on top of the carpet. It floats. And when it was in this stage that you see now, you could take a hold of one of those vertical posts and shake it, and it would shake everywhere. And then as I started adding more and more structural pieces, the whole thing firmed up, and it really, really got firm when I put the plywood on. These are the connectors. Magnus and others have covered this, but this is really important. And something that wasn't mentioned very much was there on the right, you see a black T connector. That thing that sort of looks like an oval is an oval, and it slides into the slots in the aluminum, which you can see right here below this. There's a slot there, and it slides in there, and then the bolt comes down through the connector and into that T-nut. I bought a DeWalt 12-inch miter saw, which is a chop saw that also does a whole bunch of other things. And I use 12-inch by 96 tooth carbide tip blade, which was previously mentioned and works just amazingly well. Here's some of the pieces bolted together. The one that goes from the center back towards the back is just sitting on top of that other one and shows you how all these connectors can be bolted to it. So here's my 2 layers. Now you can see that my staging layer has plywood and homosote on it. And you can see the feet on the bottom left. You can see what looks like a plywood box. That's actually my staging control panel, sits in that box, and it pulls out on those common cupboard rollers. And here you're just looking down through it, that little 90-degree angle on the right center that's bolted to the horizontal there. That's how the plywood is attached to it. Just come up through it with a screw. And here's how my feet are attached. The 1x2 vertical attaches to the left side where those 2 black T-nuts are. This is my swing gate. Ordered these from 80/20. They came in an erector set style thing. I put these together in about 4 hours. Everything is all pre-cut, and you just assemble it like the way Mort did his entire layout. There's a piece on the left side that's called the receiver, and then it swings away from you. Here's my helix, bunch of stuff piled on top of it. That's actually going to be the layout. The helix is underneath that, so I use the aluminum to float the layout over, cantilevered it over the helix. That helix is 96 inches diameter. On the lowest layer, you can see 5 tracks of staging loop. This is the underside showing all the ugliness of the wiring and the tortoises and everything else in there. I crawl in under the layout in order to do anything that I have to do from the underside. I try to do everything that I can before I actually put pieces in place. But the wiring and the installation of the tortoises, that all had to be done from underneath. This demonstrates that I'm laying on the layout on the lower level. The upper level is above my shoulder there. Okay. So I call this my first layout because it's the first one that I built from scratch on my own, but I started in the hobby in the middle 80s. I'm now in my late 70s, and I put this all together myself with just my wife or somebody else help me hold stuff once in a while. The biggest thing I needed somebody else for was to turn the helix spirals cut out of plywood. I rolled that saw outside in order to work on it underneath the outside patio in my walkout basement. Thank you. Try this stuff out. It works amazingly well.
Thank you, Jim. That was a real nice summary to see a bit of a layout that's coming together. It's got some of the wiring and tortoise controls, all that underneath it. So very interesting. That concludes our individual presentations. We've got one slide here just to summarize what we have heard today. Aluminum benchwork, I think everybody agrees, is lightweight and strong. And of course, Magnus showed that with his load test in the first presentation. You've got modular, customizable systems available, the 80/20, AluSet, EasyTube is another. So there are just a bunch of systems out there. Once you pick one, you need to stick with it just so everything's interchangeable. Things are easy to adjust, move, change, rework. I know as a guy working in wood, I actually raised my layout a foot after I built the lower level. It wasn't that hard, but I could see where if you wanted to make a change like that with aluminum, it might be a whole lot easier. Minimal tools are required. I think we heard one wrench to rule them all and one chop saw. You don't need a million different Jorgensen clamps to hold everything if you're working alone. I think a lot of us do spend a lot of time working alone on our bench work. The materials cost a bit more, but are perhaps offset by the ease of construction and the ease of changing things. And as Mort illustrated, the ease of access underneath the layout, just because there's so much less framing to be in the way. I think the aluminum benchwork does help and facilitate working alone on layouts. You just don't need as many hands, but you do have to think things out before you run down to the hardware store. It's a little more complicated than that, but it gives a very clean look and essentially no mess. I suppose you have to clean up the aluminum chips if you're drilling things, make sure those stay out of your locomotive motors and electrical circuits, but essentially no mess. You don't have sawdust all over the house that you're continuing to clean up. So that's just a very brief flyby of a summary just to wrap things up. Yeah, I want to thank everyone for participating today, all our speakers, and all the folks that asked questions and that have joined online here. So now everyone can head off and start building with aluminum. The future. Take care.
Thank you.
Great presentation, guys.